Suppose you have your own choice to print the currency notes. How many minimum number of notes are required such that you can pay a desired amount between 1 to 1000 twice out of them? Also tell the values of all these currency notes. For example, out of rupees 5, 5, 10, 15 currency notes, you can pay rupees 5 twice like rupees 5 and rupees 5, or you can pay rupees 10 twice like rupees 5 plus 5, and in second way you can pay it like rupees 10, or you can pay rupees 15 twice by using 10 and 5 rupee note or directly 15 rupee note. You are watching Brain Exploders, the world where brain starts working. So let us first get a more clear idea of the question. Suppose you have some currency notes A, B, C, D, E, F, etc. Now, if I ask you to pay rupees 231 twice out of these, so you can do it in two ways. Here, it should be possible that some of the currency notes are making a sum of rupees 231, and when we remove these currency notes, like when we remove A, D and F, because they are already used in the payment, so even then also there must be some currency notes remaining which are making a sum of rupees 231. So every time this should be possible. You can make the currency notes, you can print the currency notes all of rupees 1, like rupees 1, rupees 1, rupees 1, and so on, 2000 currency notes of rupees 1. But these are too much in number, and our task is to minimize this number. Means we can, if we are printing our first note of rupees 2 and another of rupees 1, then there will be 1999 notes. So it is decreased. We have to minimize it as much as possible. Now let us see the solution. Since we know we have to pay all the amounts between rupees 1 to 1000, so we must be able to pay rupees 1 also, and hence there must be a currency note of rupees 1. We should be able to pay rupees 1 twice, hence there must be one more currency note of rupees 1. Now we can pay rupees 1 in two ways. First currency note of rupee 1 or another currency note of rupees 1. If we have to pay rupees 2, we can do it in one way out of these, like rupees 1 currency note plus rupee 1 currency note. If we have to pay it in another way, we must include one more currency note of rupees 2. Now we can pay from these, we can pay rupees 3 also, like rupees 2 plus rupee 1, but we cannot do it in another way, so we must include one more currency note of rupees 3. Now we can pay it in rupees 3 in two ways. For rupees 4, here also we can pay it. Now there must a confusion may occur over here, like some people can do it like this: rupees 1 plus rupees rupee 1 plus rupee 1, and another like rupee 3 plus rupee 1. But this is wrong. Why? because here you have used both the currency notes of rupees 1 with 2, so no currency note of rupees 1 will remain over here. Hence you cannot pay rupees 4 in two ways with this much of currency notes, so you must include one currency note of rupees 4 also. Now you can do it in two ways. For rupees 5, here it is possible to pay rupees 5 in two ways, like rupees 3 and uh, rupees 2 with rupee 3 make a sum of 5, and rupee 4 note plus 1. In this way we can proceed. Here you can pay rupee 5 also. You can pay rupee 6 with like rupees 4. No, you cannot pay rupee 6 twice, so you must include a rupee 6 note also. Now from here you can pay rupees 7 by 4 plus 3 7 and 6 plus 1 7, and you can pay rupees 8 like rupees 6 plus 2 or rupee 4 plus 3 plus 1. We cannot pay rupee 9, so we must include a rupee 9 note. But in this way, if we proceed, this will be a long procedure. Here you can observe that the next term which we are including is depending upon the sum of previous terms. Here the sum was here the sum was 1 plus 1 plus 2 4, 4 plus 3 7, 7 plus 4 11, and 11 plus 6 is 17 rupees 17. So and half of 17, its sum is 17 up to here, and half of 17 is 8.5, and if we take its integer part 8, hence here it is possible to pay all the values from 1 to 8 twice. That's why we have to include a rupee 9 note. In any other combination also you can see it. Now here a 9 is increased, so the new sum is equal to 26, that is 17 plus 9. Now if we take half of 26, that is 26 by 2, which is equal to 13. So we are able to pay all the values from 1 to 13 twice. You can check it. Suppose you have to pay rupees rupee 12. Okay, so let us take 9 plus 3. This is making a sum of 12. So we have used 9, we have used 3. Now in another way we can do it like rupee 6 plus rupees 4, it is 10, plus rupee 2 plus rupee 1. Here another there is no need of this 1. Here also it is making a sum of 12. So our observation tells us that if we take the sum of previous n terms and divide it by 2 and take its integer part, this function represents greatest integer function. If we take its integer part and then add 1 to it, then it gives us the new term, and in this way we can proceed. So it amounts from 1 to 13, so there was a need of 14 over here. Okay, so this is correct now. So now the total sum is rupees 26 plus 14, which is equal to 40. Half of 40 is 20. So we can pay all the amounts. We are able to pay all the amounts from 1 to 20. So the next number which we should increase is rupees 21, and in this way we can proceed. Now you can see on the screen that we need minimum 18 currency notes, and the values of all these notes are shown on the screen by their sum and step-by-step procedure you can see here. So this was our solution. Don't forget to like and share our video, and for more such videos subscribe to our channel Brain Exploders. Thanks for watching.